All right, this video is to help you understand what a polynomial is and how we can use them as far as evaluating functions, or how to evaluate a polynomial as well. Just a little bit of that. So first of all, realize that a polynomial function is basically just a function of a whole lot of terms added together, fairly basic terms. Terms with a coefficient, or essentially a number multiplied in front of an x, and then x can be to any power. And then again, we add that on to other terms with coefficients with x's to powers. And when you add all those up, you get a polynomial function. The exponents are required to be whole numbers, so any negative exponents or any irrational exponents, fractional exponents, rational, fractional exponents would make non-polynomials, and we'll deal with those later in later chapters. But for now, we're trying to keep it very simple. N or n minus 1 or all those exponents working their way down all need to be nice whole numbers. Coefficients of those numbers just need to be real, so they can be fractions or irrational numbers. Anything is fine for a coefficient. Just realize again, those exponents need to be whole. The leading coefficient is the coefficient in front of the term of highest degree. And I guess before we need to know that, we need to know what that degree is. The degree is that highest exponent. The highest exponent, typically in standard form, as we note at the bottom of the screen, would be the term in the front. Therefore, we call that, again, the leading coefficient. It's going to be the coefficient in front of the term on the far left side, because we typically write them from exponents being highest down to lowest in order to make standard form. Finally, the last term that you need to know is what's called the constant term. And again, that's the last term to the right in standard form, or the term without an x. It's just a number, a sub 0 over here, just a number to the far right-hand side. There are different types of polynomials, and they're all ranked by degree. If your degree is 1, we've studied linear functions before. That has an x to the first power. That's the highest exponent you would see. Quadratics, again, we've studied those as well, are terms where you have x squared at its highest. The highest degree would be a 2. A cubic function has x to the third as its highest term. Quartic, x to the fourth, and quintic, x to the fifth. There are a lot of other names you could also use, but those will be the only 5 we ever refer to. And in fact, for the vast majority of them, if your term is greater than that, or your degree is greater than that, we'll just say it's a 6th degree polynomial or a 9th degree polynomial. So it's a great way to rank those polynomials so you have an idea what they look like if you went to make a graph. Now, one thing you can do with polynomials is evaluate them. And this is what's called direct substitution right now. If you wanted to find f1, given f of x up here is a quartic polynomial, notice 5 times x to the 4th power, leading coefficient of 5 and constant term of 14. The biggest thing is we're just going to take that 1 and plug it in for x. So I'm going to take out x in each of the terms where there was an x, and now say that this is 5 times 1 to the 4th, minus 21 times 1 squared. Again, take out x, put in 1, and finally add on 14, or our constant term. If you type that into a calculator, you'll find out your final answer is negative 2. Go ahead and try the other 3 that are on the screen right now. I'll pause the video now and fill in the numbers for you. All right, when you're dealing with f of negative 2, again, don't forget to use parentheses on here. The biggest thing is you need negative 2 to the 4th and negative 2 squared. And when you type those in very carefully with parentheses so that your negative number also goes to the power, you'll end up getting 10. Down here at the bottom, it's a much simpler polynomial. You'll notice a lot of our coefficients are 1s or negative 1s, which means when you plug in 1, it becomes 1 to the power, and you're just adding a whole lot of 1s to negative 1s, and you should have ended up with negative 9. And again, the same thing with 2. Don't forget all those parentheses. Simplify each one of those 2 to the powers. Again, the odd ones keep the negative around. Even powers, again, negatives disappear. And then all those extra negatives from the subtraction. Finally, you should end up with negative 12. So that's evaluating, again, using direct substitution, just plugging in a number for x. One other thing you might want to do with polynomials is be able to tell if something is or isn't a polynomial. So when we look at all of these polynomials, first thing you want to recognize is over here, we've got x squared and x to the 4th. Though we're not in standard form, right, x to the 4th would have been in front, those are whole numbers, and all of our coefficients do seem to be real. So I would say that yes, this one does seem to be a polynomial. Whereas over here to the right, notice we've got 3 to the x power. Since we don't know what x is, we don't know if that's a whole number. And remember, if our exponents need to be whole, this one would not be a polynomial. The exponent's not guaranteed to be a whole number or an integer, right? And in fact, even better than saying integers, we should say whole numbers. Because -1, technically over here, is an integer. But again, we don't want negative exponents. So again, that would be another reason, since this stands for 1 over x, another reason why we would not call that a polynomial. Finally, down here, if we look carefully, x to the first and x squared are great for exponents. And remember that your coefficients, √2, pi, -1/2, just have to be real. And those are all real numbers. So again, this would be a yes, whereas this f of x and this f of x were definite no's. Last thing is just being able to identify all those parts. So why don't you go ahead and pause the video now and see if you can fill in the columns. I'll fill in one column at a time and then kind of work our way to the rest. All right, I filled in the degrees for you here. Basically, these degrees will tell us what the names of our polynomials are. Okay? So I looked at the term of highest degree and said, well, hey, x to the first is the biggest exponent I see. That actually also tells me that this is a linear function. Looking over here, we've got a squared, but we also have a third power. Third power tells me that the largest degree we have is a 3, therefore it is a cubic function. If the largest term you have is a 2, again, we've already studied those. Those are quadratic functions. The largest term you have is a 5. Notice 5 and 2 are the only things you have. So x to the 5th wins. This becomes a quintic function. Right? Think of if someone has 5 babies, they have quints. It's a quintic function. Notice here we don't have any x's at all. So if the highest term we have is essentially x to the 0, remember x to the 0 being equal to 1, then that's a 0 degree. And we call this a constant function. You're just a nice horizontal line or a constant function. And then finally, looking here, we're not in standard form, so look carefully. You can't just look at x squared. You've got x to the 4th. But again, this becomes what's called a quartic function. Or think there's 4 quarts in a gallon. That's a quartic function. Next thing to fill in would be our leading coefficients. Again, find that term of highest degree. So here was x to the 1st, and 3 is our leading coefficient. In the next one, we also get 3, as this is x to the 3rd, and that's 3x to the 3rd. Here we had 5x squared, so leading coefficient is just the 5. Remember, don't write the variable down, just its coefficient, just the number in front. Here we get a 2/3. Down here again, since we only really have one term, that's a 4. And finally, don't forget, go to x to the 4th here. Your leading coefficient would be a -3. Lastly, we've got our constant term. And again, that's just the term without the variable. So here we just have 7 at the end with no variable along with it. 16, -7. Down here, notice we don't have anything that doesn't have a variable next to it. So essentially, a +0 at the end would make our constant term 0. This already was a constant term. Remember, technically that variable is not there. So this is really just 4 again. And finally, the last term would be a -7. I hope that helps you with polynomials, with definition, and how to identify the parts. Good luck and have fun.